Okay, so let's take a look at an example of where we find vertical asymptotes of any given function. So the first step we're going to do in finding vertical asymptotes is we're going to factor the numerator and the denominator. Remember, a rational function has a polynomial in the numerator and a polynomial on the denominator. We know how to factor polynomials, so that's going to be our first step. If we can factor it, we're going to factor it. The next step we're going to do is we're going to cancel it. Many people love canceling. Once you have our little individual factors there, if you have factors on the top that are the same as factors on the bottom, go ahead and cancel those. Cancel everything you can. Then any zeros of the denominator that are still left, these are going to be vertical asymptotes. So after canceling, if the denominator ever equals 0, those x values that make it equal to 0 are vertical asymptotes. So let's take a look at an example. We're going to find the vertical asymptotes of f of x is x plus 3 divided by x squared minus 9. So we see the first step we're going to do is we're going to factor this. So if we have x plus 3 divided by x squared minus 9, this is now x plus 3. The denominator will now factor as x plus 3 times x minus 3. Now we factored this. Now we're going to go ahead and cancel. And so what we now get is we're going to get 1 divided by x minus 3. And so this is what we're left with once we cancel any of the terms. And so this now tells us what our vertical asymptote is. So we see that x is equal to 3 is the only vertical asymptote. So the only x value that makes the denominator equal to 0 at the end is x is equal to 3. So that is our only vertical asymptote. Now, we might have a question of what happens to this other term, right? Because if you remember looking at domains of functions, you should remember that anywhere the denominator equals 0 is not in the domain. So here, when we look at the denominator, we see both x equals 3 and x equals negative 3 make the denominator equal to 0. Now, this is a different function. 1 over x minus 3 is not the same function as this. For the sake of finding vertical asymptotes, we can treat these algebraically as the same, but this function is different than this. Because here, you could plug in x equals negative 3, and you could evaluate that as 1 over negative 6. Here, in the original, you plug in x equals negative 3, you get 0 divided by 0. You're never allowed to divide by 0, so negative 3 is still something that is special. There's something going on with our function that is not in the domain, but it's also not a vertical asymptote. So that leads us to this next question here. What happened to the term that was canceled? So we canceled out this x plus 3 term, and that no longer made the denominator equal to 0. What happened? So we have this definition. Any x values that originally make the denominator equal to 0, but are not vertical asymptotes, so they get cleared out of the denominator in the canceling step, these are going to be holes. A hole is going to exist at a point corresponding to that in our graph. So if you were to graph this onto your graphing calculator, you could see what this function looks like. And then if you look at it, you're not going to notice a hole. But if you go to the table and you go find in the table x equals negative 3, you're going to see either an error or does not exist or something like that. So if we were to look at the graph of this, x equals 3 is a vertical asymptote. So we'll use a dotted line to indicate that. And then if you were to sketch this off of your calculator, it would look like the following. It looks like this, and then it looks like this. But there's a hole that exists here. This is not defined. So how we indicate that on our graph is we put an open circle there. So that open circle says I'm not defined there, but I'm defined everywhere else near there. And so this is what the graph of x plus 3 over x squared minus 9 looks like, and that has both a vertical asymptote at x equals 3 as well as a hole at negative 3.